Good morning, everyone. Good morning. I'm Sandy Papadimitriou, and I'm a deployment strategist at Palantir. I'm based in New York City, and I'm thrilled to return to the Gen AI Summit. But this time, I'm joined by my seasoned colleague, Theodore Varvadukas, who is an enterprise lead at our company.
Hey, guys.
So, can you please raise your hand? How many of you have heard of Palantir? Okay. So you might have heard of Palantir from different sources. Some of you by our leading work in AI, others by maybe the financial news, because now we are the third best performer in S&P 500. Woohoo! So what is Palantir, though? Who are we? We were founded more than 20 years ago, post 9/11, to provide technology to the government to manage massive amounts of data while protecting civil liberties. Since that time, we have expanded our work, working with other international governments and commercial partners, primarily Fortune 500 companies and medium and small-sized businesses, always tackling the most challenging, innovative, and meaningful problems our world faces. For example, you might have heard that we provided a platform to support the COVID-19 vaccine rollout during the epidemic, and also we powered operations in Ukraine. So right now, we have a lot of innovations in technology, new models in AI, a lot of other technologies coming up, but one thing has remained constant for the past 20 years. Work is only meaningful if our product and our work changes operations of the front line. And this is why Theo and I are here today to show you how platform works and run through a live demo of a real-world application of our AI in a product.
Sure.
Theo, do you want to kick it off and show how platform works?
Yeah. But just before I start, guys, FYI, I already messed up the presentation. I confused Sandy already. But,
no, that's all.
but let me start with something very important about Palantir. The company, the way we're building products is by having some sort of philosophy first. We have an opinion about how the world should work, and then we try and encode that into technology. But you know, that's not easy to do. But let me go back a bit and talk to you a bit about how I joined Palantir, which actually is, I think, 8 years ago, around November 2016. My passion always was intelligence. I studied computer science. I studied AI back in 2010. And at some point, I read this article by an ex-Palantir architect, Ari Gesher. And you know, it was on that blog post, it's already archived. It's not even out there anymore. He was talking about a chess tournament that took place in the past. You know, in chess, when we play tournaments, we're not allowed to use engines, or we're not allowed to talk to people. But that specific tournament, it was actually freestyle. So you could do whatever you wanted. You can use engines, you can use grandmasters to talk to and get advices on. So surprise number one back then was that some grandmaster plus an engine actually outperformed the best computers and also the best grandmasters out there. So that was pretty cool. But the even more surprising thing was that the winners were not very good chess players. They were actually two super average chess players. They used 3 computers, not great computers. But how did they do it? They had a fantastic process. They knew how to, you know, sort of challenge the machine, get something back, challenge the second machine, and so on. And you know, it was at that point that people realized that the glue, the interface between things, actually matters. And now, you know, reading this article, it made sense to me. Palantir's philosophy is exactly that, and we deploy that against real-world problems. So it was a natural choice for me.
That's a very cool story.
Cool. Now let's talk about Palantir's artificial intelligence platform, and you'll see the connections with the story that I just made. So let's start with that philosophical question again, which is what is needed for AI-powered operations. Everyone is familiar with the paradigm on the left, which is the classic chat paradigm. ChatGPT. Maybe you have some other applications where you maybe upload some PDFs and then you chat with your PDFs and so on. But that's not how big enterprises are working. If you really want to bring LLMs and Gen AI into large enterprises, you have to do something different. And this is where AIP is sitting. So it's in the middle of connecting existing infrastructure. And these big organizations, they have shitloads of systems. It's systems of actions. It's data systems. We're talking about hundreds of systems. And then you want to connect that to decision makers. So the people in the organizations, operators, analysts, managers, whatever. And of course, you want to connect all of those with enterprise LLMs, be it commercial, open source. It doesn't really matter. AIP is sort of agnostic on the underlying technology. Now, let's see how we actually embed AI into operational decisions. So the classical flow of decision making is you have a user or a team of people. Initially, they sort of acquire knowledge somehow, then they reason on it, and then they take some action, and sort of ends there. The way we're thinking about AI is that you really have to embed AI in every step of the way. That's very key. So, initially AI can help people to bring in context. They can co-reason with humans, and of course, they can take actions either autonomously or even collaborate with human operators. And the operator can also give feedback to the AI and sort of collaborate, and then take a decision, take an action, capture that decision, and then compound that knowledge back to the decision process. So the very important, again, philosophy, but applied philosophy, I promise. The very important thing is you cannot have humans and AIs being on different spaces. You cannot have engineers building AI somewhere else and then humans being somewhere else. They really have to share the exact same decision model. They have to be operating on the same stuff. And now I'm going to take you to our secret sauce. It's the second philosophical concept, but it's real. We're going to show you a demo later, which is the ontology.
And you guys might be the only people who can know what the word means. Ontology.
Let's imagine that I'm a supply chain manager, and what you see in the picture is sort of the ontology of my organization. These are the things I care about. So, of course, initially, you always have data. Data can take any kind of form. We're talking about structured, unstructured data, Excel files, whatever, knowledge in the minds of people of the organization. It doesn't really matter. At some point, you have to integrate everything together. And of course, we don't want to talk about tables and rows in the end, because that's not how business is talking about things. We want to talk about real-world concepts. And if I'm a supply chain manager, I talk about customers, and I talk about plants, cost of goods, and manufacturing capacity. These are the concepts I really care about. And then the next thing that we have in an organization is what we call enterprise logic. That is effectively how the organization is working. We're talking from simple process-based, rules-based processes all the way to more sophisticated stuff, like I have my forecasting model, forecasting capacity in my plans, or I have my production optimizer, and so on. When we have LLMs, we really need to anchor them on both the data and the logic of the organization, or else they can go hallucinating whatever they want. So given that we have data and logic, we're ready to take decisions, but decisions without acting doesn't really make any sense, doesn't make any difference to the world. So the last concept that sort of concludes the ontology is what we call actions. And so in large organizations, usually when you take an action, that means you sort of write back to a system of action, an ERP, a transactional system. The other super important concept, because we just talked about the system that is enabling human plus AI teaming, now I really want to talk about the teaming itself, which is humans and machines need to be in the same space. They need to collaborate, and you cannot do that unless they live in the same interface. So again, I'm a supply chain manager. I have my UI every day. This is where I do my work. I really want AI to be there. I will never, for example, label data when my job is done and I go home, right? So it really has to be there. The LLM needs to learn from the human. The operator needs to give feedback to the LLM, and that's where the compounding is happening. My last slide. I just want to talk about the levels of AI, especially in enterprise context. That sort of, it's a nice framework to sort of position a few things, position maybe workflows or maybe an organization at large. Effectively, thinking how mature am I in the adoption of AI. So let me take you through all these levels. So level 0 is like classic data processing. I'm just using the LLM. I give it a text input. Usual workflows there is summarization or entity extraction, and I sort of get a text back. Very simple case. Level 1 is when LLM becomes a bit aware of your data. So we give it access to the organization's data, and some workflows there are chat applications inside organizations. The LLM sort of knows things, and you can chat with it, but it sort of ends there. Level 2, I think, is where it gets interesting. It's where we actually have influencing on decision making. And it's at that point where LLMs know your logic of the organization. So they're aware of how you're handling things. They're aware of how do you handle tickets, for example. How do you handle disruptions, usually? And at that point, you give access to your LLM to logic inside the organization. It could be in the form of PDFs, where they understand how you work by reading the PDF, or through actual APIs, for example, that I can have my forecasting model somewhere, LLM can call it, and so on. And then level 3 and level 4 is where I believe the real winners of this hype are going to be. Here, it's when we integrate human in the loop. And it's, the human is actually giving instructions to the LLM, they collaborate with the LLM, and so on. And then level 4, of course, is the truly autonomous version of that, where you have LLMs autonomously acting, but we always need humans to be operating, monitoring at scale, whatever the LLM is doing. I'm going to end up here, and I hope that the demo we're going to show you is going to put some visuals on the abstract concepts I just described. Cool.
Thank you, Theo. It's actually funny. We're a no-slides company. Even when we talk to customers, even the C-suite CEOs, we always just do demos, because I think the demo will speak volumes compared to just a slide of words.
And yeah, I have to log in.
Oh, wow, yeah. So today, I want you all to put your supply chain hats, because when we're going through brainstorming of what to show you guys, by the way, we're industry agnostic. We work with customers from all industries all around the world. So, but I think just for illustration purposes, it would be great to show you something that's very tangible. And to be honest, it's a problem that many customers across different industries face. And that is, how can I manage my supply chain? And by the way, what you see here is Foundry. This is a platform. This is a user-friendly application, but there's so much happening at the back end through the ontology, what Theo just walked you through. So here, I'm an operator. I'm leading the supply chain of my international company. And what you see here is a graph where I have added data, logic, and action through my ontology. And let's actually start with an example. Let's start with Boston. So I have a manufacturing plant in Boston. And in this UI, with a click of a few buttons, I can see all my systems connected, all my ERPs, anything that has to do with my supply chain, my inventory management, my demand forecasting. So I bring in data, anything from structure, form, anything from the traditional tables all the way to my operators at the factory where they have handwritten notes. I capture everything and add it to my ontology. And then on top of it, I add the second layer of logic. This could be traditional ML models of my demand forecasting or inventory management. And then I add the third level of my ontology layer, which Theo mentioned, is actions, synthesis of actions. So today, Theo and I will give you a demo of how we can use Foundry as a basis of automated AI-driven powered decision processes which brings together logic and systems of actions to enable AI-powered processes with intuitive human handoff. So as I can see here, I can see where I have any disruptions in my supply chain, anything that looks fishy, or anything that, something is bad, and what will be the outcome in the downstream. Usually, those disruptions come in the form of tickets, anything from email notifications all the way to my alert inbox. And as you can imagine, a lot of times this is in a free-form text. For example, let's see here. Yeah, there's a blood pressure monitor inventory has hit 0. Oops, that's bad. And usually that translates to millions of dollars in losses downstream. If something happens in my production line, of course, this translates to something wrong happening down in the rest of the workflow. Cool. OK, so let's go and see how my ontology looks like, and see how this specific, let's just pick any random one, how this specific problem and the ticket that I received translates in my ontology. I can see that this specific one, again, it's tied to the Boston manufacturing plant. And here, with a click of a button, I can see what kind of customers are impacted, and more details. I can dive deeper into the details. Theo mentioned earlier that I think it was level 2 or level 3. Yeah, so we can use AI to ask questions and get better idea of our data. I think the majority of the audience here has used ChatGPT to ask questions, anything about a cooking recipe all the way to some more exciting ideas like help me plan a trip to Asia or something. Let's use the chat to ask questions about this specific ticket. Let's do, OK, what customers will be impacted? So, yeah, we can use AI to parse through my ontology and get real data about this ticket and see what will be the impact, or it can even run through calculations. Yes, we can do that, but there's just way more things we can do with AI, and that could be more transformative in my operations. So we can take a step further and inject AI and that whole level of ontology, data, logic, and actions again, and actually transform the decision-making of my operators. Because if you think about it, as a company, we have two problems. The first is a knowledge capacity bottleneck. For example, a knowledge bottleneck. I cannot know everything about my operation. This is why ontology here comes in handy. And the second problem is that sometimes I only have 10 people going through those tickets. And I don't have time. I don't have capacity to go through every single ticket manually. And this is why we're going to automate this process by creating some AIP agents.
Cool. Sorry. Let's imagine now that we have all of the tickets that Sandy was talking about. They're here on the left. There are new issues that could be coming from whatever systems we care about. I actually built an agent that is going to process all of these tickets in the background. And I want this. I'm just going to show you the underlying technology. The agent is going to go through the tickets, process them, resolve them as much as it can. And the idea is that we have, I've told it hey, these are two solutions you can figure out if you can, but if you can't, push it back to the human, hand it off back to the user. Let me go through this tool. This is AIP logic. It's one of the many tools in AIP. And the way to read it is from top to bottom. It's like you have an input, every block has an output that becomes an input to the next thing. So at the top, I really start with a ticket. That ticket is not like any random piece of data. It's something already modeled in my ontology. It's what everyone in the organization is seeing. Let's go through the next block, which effectively I'm telling the LLM to extract some key details from this ticket. Now, I also want to enrich this information, and we go now beyond prompting. We're not just chatting with the LLM. We're actually instructed, and we define how do we want the LLM to execute the entire process. So specifically here, I just tell it, extract some key information and so on, but I also give it access to tools. We talked a bit about level 1, give access to data. So here, for example, I say, hey, you know what? If you want to know something more about customer orders or finished goods, you can query the ontology. These are the 2 objects that are available to you. In this way, we're sort of solving another issue with LLMs, which is hallucinating. And sometimes they're not just hallucinating text, they can hallucinate whatever. So this is another way to constrain it. And then downstream, the other thing I want to do is sort of say, I can give you some access to PDF documents in the organization where I describe policies, how do I generally handle disruptions and so on. And finally, I just want to bring everything together. And this is effectively the block where we want to leverage the PDF documentation and also leverage past knowledge from the organization. We're approximately level 4 right now and level 5. And so it's at that point where, on top of giving it access to data, what you see as principles here is PDF information. It has done some semantic search in the block above, but also I give it access to past support tickets, where they can inspect how previous tickets were resolved, and they can get inspired from previous solutions. But also, the other super cool thing is that I give it access to a function, specifically, which is inventory reallocation. That is a model that was written by data scientists in combination with business users, and we know that LLMs are not very good at quantitative stuff. So someone really smart in the organization wrote this model, and the LLM can just use it, can offload that piece of work on that model, and then get back an output and figure it out. So the LLM here is acting as more like an orchestrator rather than a question and answering machine. I don't want to take you through the exact specifics of the prompts, but effectively, first solution is like, try, in case of a disruption, try to reallocate inventory. If it exists in one distribution center, take it from there, put it in another one. And if you cannot do that, go to solution 2. If we don't have, for example, one material, can we substitute it with another material? But then, critically, finally, if you cannot find a solution, please offload it to the user. And finally, as we said, there's no point in just taking a decision without writing back somewhere. And so the final step would be that I give it tools to really write back to systems of production. In this case, for example, it can be that the AI finds a solution and we want it to edit the customer order, or let's say it's substituted materials, we want to edit that order, and also we want it to update the ticket. It figured out a solution or not. The super important thing is that these exact same actions are the actions that human operators are using. So you remember before we were talking about that shared model, shared interface. These exact actions are backing the human UI. So let me go back to that view we were before, and now we can see, for example, that on the right-hand side, the AI already resolved some issues. We can inspect some of them. Actually, in this case, there was no action. Let's see another one. Cool. Inventory reallocation was successful. This is all good. As a human operator, I can just sanity check that. But the other cool thing, as we said before, is that there were some tickets that actually the AI couldn't really find a solution. And now it's pushing it back to the user. So we see that synergy. And I can give it some feedback. Based on that feedback, it can trigger the same actions again. I want to leave some time for Q&A. So I'm not going to show you more stuff. I just hope that what you saw on the visuals sort of brought all these concepts together.
Yeah, and the cool thing is that what Theo just walked you through can be completely automated. So whenever we receive a new ticket, again, either in the form of a text, email, maybe a voice message from the operators on the ground, will be automatically go through the process in the pipeline and will be processed without someone actually manually taking an action. But again, if our AI agent thinks that there is not enough documentation, it will go through the very robust governance rules that Theo showed you in terms of feedback, and it will raise an alert saying, hey, operator, there is some ambiguity here. Can you please manually review it? And then we will use this action to feed back to our AIP agent for future reference in terms of a more enhanced documentation system. So what Theo and I show you today is that we built a digital twin of our notional organization. We built the ontology, which includes, again, data, logic and action. And then we used AI, we injected AI in the processes, and this helped us address two issues. First, we helped them understand what they're all the data in the organization, and then two, act on it and automate the process in order to make it significantly more efficient. And again, this translates in significant revenue to them, profit, and of course, making sure that all the operations run as smoothly as possible. So we have 4 minutes left. We should open it to Q&A. Do you guys have any questions?
Yep.
Do we have microphones? You can always repeat the question.
Just shout. Here in the front.
Thank you. 1, 2. Thank you. Great presentation, both of you. A quick one regarding the models you're using. Are you hosting any models, any open source ones? And if so, I was wondering how much infrastructure you have to use, to give all these kind of solutions.
Yeah, we do host models. Actually, we're so agnostic that we do any kind of combination. So it can be custom models from an organization. They have fine-tuned, for example, something. We've built a lot of services. These are the available ones in this specific platform. Llama, for example, is self-hosted. We have a specific infrastructure that sort of caters access to these LLMs, which is sort of unifying, sitting on top of any kind of LLM and standardizing everything. We call it the LMS service, language modeling service. But yeah, pretty agnostic. We do all of these things.
Just something to know, because security is actually the foundation of our platform, and this is why we're trusted by both governments and commercial partners. All these models go through extensive testing before they integrate into a platform. And also, we enable the capability for the workflows to be upgraded to the newest model. And we also encourage customers to use more than one in the workflow to perform different operations.
Yep.
Thank you very much. That was a really nice speech. I have 2 questions. This very impressive interface that you're showing here, is it you that you set it up or the client?
So the entire thing, it's a logic, it's an application in Foundry, in our also in AIP. The specific blocks is what we set up. And then the previous application that you saw before, we built it, but again, with a lot of tooling coming from Foundry. Generally, Foundry, you should think of it, and AIP at large, you should think of it as an operating system where it gives you all the tools to do things like that, sort of empowers you to do that.
And just to add up to that, the cool thing is that, as you can see, most of the context here on this AIP agent application doesn't require coding. So we have users who are less technical, or maybe they just don't want to write extensive lengths of scripts, and they can use it as well. And earlier, Theo walked you through how we applied embeddings to unstructured data. Again, our product has done extensive work to add all those enhancements to the product, and someone with a click of a button can apply embeddings to the input, the unstructured input. Excuse me, what's that? Yes, yep,
Yep.
yep. Oh, and it takes only a few minutes. It's very quick. I think we have one more question, just one more.
Yep, on the left.
I would like to ask how the testing happens when you change something. For example, you change the model, you
Yep.
change the logic. I think this is very critical.
So we have a framework that we call evaluations. And here, for example, you can start building test cases. But the evaluation framework is actually, we're actually building it right now, just to be super honest. We have early versions of it, and I believe we're already ahead of the market. But what we do generally is we have, the idea is that we have LLMs sometimes either evaluating work of other LLMs, but also humans sort of providing the framework of how things should be sort of marked. Like, is that a good answer? Does it contain the right pieces of information? Is it okay with my privacy and compliance and security principles and so on? And it's a very extensive framework. The way we're thinking about it is you have, let's say, for every new workflow, you can set up, I don't know, 10 test cases. It doesn't need to be hundreds. And you build those 10 things that are constantly running. Like, it's like health checks in code. When you deploy something new, you want to be checking that all of the previous work is still working. And so that also ensures that not only we know that things are working okay, but also that upgrades or a change of LLM, all these things do not really break my workflows. And I have sort of an expected answer and behavior back.
We're about time, but Theo and I will be outside. You can catch us during break if you have further questions. Thank you so much for your time, and excited to meet you outside during the break. Thank you so much.
Very much.